So this session is about understanding what all, how do we navigate new code bases, right? So we get thrown into, not thrown, yeah, we get started with the new projects, let's say, and you want to navigate that code base, you want to understand the overall system. How would you go about it? So this session is about that, right? We are taking an example of Ultralist, which is a to-do application essentially. So it's a very simple to-do app. Overall, this app is very simple that way. But the idea is if we can apply these techniques on our own projects as well, that's the main going to be the main takeaway. So before we go ahead and jump into the code, let's first understand what we are talking about, right? So the first step, I think, is to know what you are getting into before even jumping into the code, is to actually try and use the product, right? So we'll try and go to Ultralist IO and see what it does. So this looks like it's a command line utility. So, and you can see the to-dos, and apparently, I guess these are priorities. Then this is probably a checkbox whether something is completed or not. And then there is grouping in some way, like maybe a project grouping that we saw. All right. So, and it says it is based on getting things done framework. So yeah, something about that as well. It has concept of project context and due dates. Okay. Yeah, tasks can be prioritized, completed, archived, etc. And it is primarily CLI based, so we can also, it looks like it integrates well with other CLI features, other Linux CLIs like grep, filter, op, etc. And then there is a pro version where I guess we get a web app as well for that, web app and maybe mobile app, I'm guessing. Right. So purposely, I'm taking this a very small, simple example where the domain is not that complex. We all can understand what to do apps could be, right? So what we want to do is understand this code and try and explore this code. Yeah. So first step in it, before you even go and understand, the first step would be to actually try and use the product and try and understand the domain itself. So the domain is pretty clear that it is a to-do application. So let's try and use it. So what I've done is I've installed Ultralist locally using brew install. And if I see Ultralist L, okay, it says no to-do file found. I can initialize one. So I've done the initialization in a to-do in Ultralist to-do repo. Here you will see that there is a file that it creates. So let me try and create let me remove this to-do JSON file and create Ultralist. Like L looks like for listing. So before even, like, you can just run the basic Ultralist command and we see that there is add note, archive, bunch of things, right? And -h for help. So let's say if I try to list the to-dos, there are none right now. So that's why it says no to-do file found, and gives me a helpful message that you can run init. So let's see what happens when I run init. So okay, repo initialize. Not sure what that means. So if you try and check, it creates a to-dos.json file. So one thing that is becoming clear is that it uses a file system or a single file as a database of sorts to store the to-dos. It does not use any backend database like Postgres, Mongo, MySQL, etc. Right? It is purely on a local machine. There is no server involved right now. That's what it looks like. So what I'm trying to do is I'm trying to figure out what all are the component or dependencies for this that need to be installed or that need to be present. Right? So just looking at this JSON file, it looks like this is a simple CLI with the data captured in a JSON format in a single file locally, right? So just based on their documentation, what I've done so far is I haven't gone through the code, but I went through their docs quickly so that we can prepare for the session, and gotten some tasks and some to-dos created locally. So there are these commands like you can create a to-do, you can list, you can complete, you can archive, then you can filter, you can group, you can do a bunch of features, right? So let's just, I've created a scratchpad to do some of these. So let's try and complete some to-dos. So looks like this was a to-do created, it was completed and archived as well. So if I wait to try and list, let's see what happens. Okay. Okay, not this list. Yeah, so it doesn't show the to-dos by default, looks like. And then we can add some more to-dos, and yeah, it shows me that to-dos are added. And then if we try to list the thing again, we see some to-dos, right? And this is pretty much the application as such. And I'm guessing then there will be to-dos will be created and added in this file. If we were to try and cat this file, let's see what that looks like. Okay, it looks like some JSON format, and we can pass it to JQ. JQ, if you don't know, is a JSON query editor, which basically is going to print this JSON in a standard nice looking format. So we can see it's an array of JSON objects. Each looks like a to-do with some fields, and then there is priority, there is status. So it's almost like a document DB in a single file that it creates, right? So what I'm doing so far is, before we go and start looking at the code base, really trying to understand what the application does by being a user of the application. Okay? This is one important lesson which is applicable across, I would say, most of the new code base that you use. You should try and use the application before walking through the code, so that you have some idea on what to expect and what you are expecting to find. If you don't actually use the application, then walking through a code is literally like walking in a maze without any feedback, right, or any direction. So instead, this gives us some idea on what components to expect, right? So if you were to draw that, it would look like there is some CLI, and it stores data in the JSON file. Yeah, there is no database, there is no other third-party component. Yeah, at least that's what it looks like by looking at the UI interface and by trying out some commands, right? So how would you discover? Obviously, there could be projects which have some sort of domain or component diagram. In that case, you are in luck, because you can actually just look at the component diagram and see what components are involved, right? So in this case, maybe there is some third-party component for whatever analytics purpose, etc. We would know about that if it's documented, if it's added in the component diagram, right? Other way to figure this out, for most projects, even if there is diagram, it may be outdated, it may be wrong. In some cases, like, the way to figure this out is by looking at application configuration. So even before you start looking at the code, you can start looking at the application configuration to find out what is the application require as a configuration, right? So for example, if it requires, right now this app doesn't have any configuration, because it's a simple CLI app, so there is nothing as part of config as such. But there are, like, typically, if you look at any web app or any app in general, it will have some config file. So how do you find where this config file exists, etc.? So one way I do that is, there is a way to run, like, there is a GitHub project called Clock. It stands for calculate lines of code. You can again download this project or CLI, etc. locally, install it locally. And one way to do this is to run Clock on a new project that you clone. Yeah, so if I run this on Ultralist, this is a repo that I clone. It does some analytics. It tries to go through all the text files. It says, okay, there are unique files, and then some files are ignored for whatever reason, and then it prints me some statistics, right? So most likely you see that this is like a Go code base where there are about 500 files. There is almost like 20,000, 30,000 lines of comments and blank code, and code is about 270,000 lines. Wow, that's quite a lot of code for a to-do app. Then there is a bunch of markdown, then assembly. Okay, that's interesting. And then there is some shell scripting, I guess, for automation or whatever purpose. There is some YAML as well. then toml file, then make file, JSON file, Ruby, etc., etc. One or small files. So looking at this, it can give you some idea on what to expect and where the configuration might be. So you may start with like YAML files, you may start with JSON or make file even for the project to understand what it's doing. Right, so for example, obviously one way to start is via README, and if it's nicely documented, then makes life much more easier, right? But if not, then you can always go through some other files, typically like how to build the project, how to what are kind of other files are there, where is the configuration, where can we find it, etc., etc., right? So in this case, the Rake file, if you don't know, Rake is a Ruby based build tool, which where you can write, this is like a Ruby code that you write, and it allows you to build and run code, right, for various environments and whatnot. So apparently this is what they use. Then there is go.mod, go.sum file, standard for typical Go applications. Then there is Travis YAML file. So it looks like for building a Travis CI is being used, and it uses like two kind of builds. Looks like OSS like Linux and OS X, and Go and whatever. Okay, it runs simple test case for Go. Right, and for typically for any Go program specifically, you can again depends on the project structure that is followed, but usually most of the project follow some structure where there is command. Right, CMD stands for command, and that is where you can find most of the commands for the project. Either these could be CLI library, CLIs itself, or these could be, now we'll see how it is implemented here. So again, every typical Go project will have some sort of main.go file. Most likely in case of web apps, it will be in the command folder sometimes, or if it's a small enough project, then it will be at the top level here. Right, so what we want to do now is look at the code base. So far everybody like follows till this point, right? What we're looking at is a to-do app which stores the data in a single file. We looked at the overall number of lines of code and some config files. There seems to be no configuration as such. There seems to be no third-party libraries, etc., involved. So now we are trying to go inside the code and see what we can find and how can we read this kind of code. It's okay. So I'm opening up main.go file. That's like the main file for the program. So I can actually also run it. Let's see what happens. Okay, it prints just the same thing if I were to run Ultralist, looks like, right? Which makes sense, because if I try to just run Ultralist, okay, this CD, yeah. So if I were to try and run Ultralist, it prints just the standard help function, standard usage, etc. So that is what the behavior we get over here. And the main function is pretty easy, that it just calls command.execute. So let's go here. And now, okay, let's try to see what this does. So here, this is part of the command root command. Now, if you are familiar with Go, to me, this looks like a Cobra command structure. So they have followed, they have used this Cobra feature or Cobra library. So Cobra and Viper are two libraries that typically are used hand in hand, and Cobra is for, if I'm not wrong, yeah, for adding commands and sub commands. So the thing that you see here, right, Ultralist list. So this looks like a sub command of Ultralist, and that is exactly how it is implemented. So there is a root command in Go using in Cobra, for example, and then each of the root command. So this root command will have sub commands for it, and each of those are implemented like files. Looks like each of them are separate files. Like for example, if you see here, there's a list. Then init was another command. We see init.go file. I'm guessing there will be delete and auth and add and sync and version and whatnot, other files. So let me try and see if that's the case. So ultralist --- help, if we run, yeah, we see add here, we see add here. we see add note, we see add note. Yeah, it's exactly like one-to-one mapping of all these commands to these files. So that is much easier to understand. So this is how Cobra really works in a way. So each of these commands then are implemented as part of these files, right? So that way there is very easy and clear separation in terms of where we can find stuff. So if you want to understand where, like how a new note addition works, we can probably go to add command. If you want to find out how to list all the to-dos, then we can go to the to-do list command, the list.go files. Yeah, this is pretty simple and interesting. Where are they using Viper? Let's see. Okay, so for config files, apparently there is a way to do some configuration, and the config path is either home or home and .config and ultralist and config name. Okay, reading config. Yeah, so apparently you can use some config file. I haven't set it up, so there was no config file by default. We can also check whether this is called somewhere. Okay, it doesn't look like this is called anywhere though. So my guess is that this code is no longer used. I'm not sure. Okay, but there is some configuration file. So if we look up the documentation, there may be some details that we may find for to-dos. Like if I were to try and guess what some configuration file that config might be for to do, it could be things like what are the config file used? Okay, not nothing. It could be things like by default, whenever we add a to do, we mark some date, mark some project, things like that, right? It could be some things around how to use the to-dos app essentially. All right, so that's all there in the CMD folder. What's there? Like, let's look at actually a simple command. Maybe list one would be simple to look at to start with. If we look at list, it has some init function. It has documentation nicely done for how do we list all the types of to-dos, like due on Monday, overdue, by status, by project. Wow, that's pretty nice documentation. Okay, that's quite a lot. Okay, then here is the, this is how, again, you'll have to know how Cobra works in this case. So we have a list command, and then we add this to root command here. So that is why we are able to run something like Ultralist and list afters. I'm guessing Cobra will have a way to add command to another command as well. Like list command can also be a parent command from some other command going forward. There is also a way to set aliases here. Again, this is all Cobra features, I believe. And the example, then long, short variations. But fundamentally, whenever we run the command, it gives us a way to run this in a function. So this is a function that we can call. Right? There are other options like this, but fundamentally, whenever someone says ultralist list and enter, it executes code here. And that code is some coloring and Unicode support parameters, but fundamentally it calls list to dos. And whatever are the argument passed, it tries to send these arguments to this function. And then there are these other, what are these? These are, some variables. Okay. So if you go here, the list to dos function, where is this function defined? So this function is defined in app.co. Looks like this is the main like Ultralist app file. Yeah, so it looks like the project structure is such that CMDs will call functions from Ultralist package. Right? And I think there are only 2 packages. Yeah. So this to do repo is nothing but something that I have created as a like the JSON file, right? But the command and Ultralist are the only 2 packages, and command package calls the Ultralist package, looks like, right? So list to dos is being called, and we can also try and check what are the other. Okay, there are a lot of other functions. If I were to quickly navigate, I see edit, add note, edit, delete, etc. So I'm guessing all of the commands will call this app.go file, because this add note looks like something, edit note looks like something will be called from add.go or add note.go. Let me try and see. Yeah, so that's pretty obvious. Like add note is being called from add note.go. Yeah, and let's look at one of them. So we started looking at to do. Here we get the input. Remember, the input that was there was all the arguments, command line arguments. It's here. This was the all the CLI args joined by a space. That was the command line argument. Okay, not sure what this a.load is. I'll ignore that for now. Then they do some into parsing the input. Okay, fine. Again, there must be some way to parse. We can try and go into detail, but okay. So there is some parser which does some filtration, parsing, etc. Okay, we'll go back for now. And if the parsing is cool, then it tries to list the to-dos here. Yeah, so this is where the actual domain logic is being called, that to-do list dot to-dos. Right, so this is where they will actually probably read the JSON file and get all the to-dos based on the filter, and then this is a to-do filter that will create, and then group them by whatever grouping, and then printing them together. Yeah, so if this is the main important function, so let's see what that does. Okay, it just sorts the to-dos by some date and returns a data. This is to-do list.go. Okay, long huge file. Going back, I want to understand where they actually are parsing the file, like reading the actual file. Is it in parse? Doesn't look like it should be in parse, because this is purely for input parsing. Oh, that's a long function. Maybe is it in a.get groups? Let's see if it's there. Okay, so we have this groups. What does this group do? Matches input. Okay, yeah, so this is where they are probably matching the to-dos by the context and whatnot. So this is just a transformation of to-dos, right? We see there is a clear input and there is a clear output. So this is purely like a transformation function, and the magic actually must be happening here. Now this could be they're not reading anything here, so it looks like they must be reading the data in it, or in some sort of way where this object is constructed in the first place. Okay, there is a lot of functions. Delete. Okay, let me try and see if I can find that function somehow. Maybe is there a file reading here? No. So is there a file reading in the overall project? Maybe that's where I will need to search. This package, if I were to search for a file. So to do store. So this is where it looks like, right? So we had this app, and which had this new file store. So this is where the app knows how do we store the to-do list. It's using a new file store. This new file store must be, yes. So this is where the loaded equal to false. So by default, it doesn't load anything, and initialize it must be loading. Looks like yes. To-do file exists, then okay, this is for writing. So there must be able to read this file also, and they must be parsing that. Yeah, so this is where load, right? So load is for loading a file either from current working directory or from home directory. So this is where they're loading the file, and then there is a clear separation of file store versus yeah. So if we were to if I'll go back and talk about the app, so app is the main construct in the code. Looks like it has it has various structs inside it. One is the to-do store, which is of type store. So the stores maybe is of multiple types. Maybe there is a file store. I also saw that they offer a pro version where you can sync files. Right now, the problem is if I run this locally, my file is only going to be on my environment, right? My local machine. It's not going to be on other laptop or other computer or other mobile device. So there is no syncing right now. And I can probably sync using this Ultralist sync command. And that means I need to, I need to share these files or read the files from some other format, I'm guessing. So that's why they have stores. So there are various stores. Okay, there are two stores, file store and memory store. Okay. Then printer is also screen printer and simple screen printer. Okay, there are multiple. So each of these look like interfaces with implementations. That's a nice way to design because we can get different implementations. We can have different implementations for each of these interfaces. One can be like memory interface, memory store maybe is used for testing purpose, I'm guessing, and file storage actually being used for real code. So far, are you following? Like I am trying to navigate the code first time as well. So okay, printer is again, yeah, so there's some formatting tab writer. Okay, so this is for purely for printing the results on where the output, right? Like if I were to do a list, I think it is in what I have a file over here to do repo, and if I were to do this, yeah, this is for the coloring and printing and formatting. They have a separate file for handling all of this. Okay, and so this at least to me, this gives me an overall idea of what the code looks like. So app is going to be the main store. Then I'll try and look at other files like backend.go seems interesting. Okay, so this is the API backend. So this comes down to, I think, this is required when we have to use a backend, when we have to sync across servers, looks like, and that is where the credentials and API part comes into picture. So if I'm even if I'm writing to-dos locally, they will be saved on the server using an API like this looks like. And so there's a perform request. So then there is this headers and tokens that they send, and the credentials, etc. So this class is all about sending data onto the backend server. Create to do. Okay, that's simple. Then filter, I'm guessing, is all about filtering the to-dos based on various options that they support: completed, archived, whatnot. Yeah. And this is a struct that they use. So with that whole struct, they can filter input parser, memory printer. Okay. To-do list seems again like a main class, which has a bunch of features like bunch of activity. Yeah, the things that you can run on to-do list. Okay, and there's not much tests look like. Okay, utility test with to-do list test has bunch of tests. Right, so this is about, I think, generating new ID, deleted to do, max ID, index of, okay, various test cases. Yeah, I guess, I mean, that is it here. That's not much to explore in the code. We can look at some other unknown files like recurrence. I don't know what it does. So okay, so this like I can create to-dos which are recurring. Like every week I want to auto create a to-do, I guess, or this to-do occurs every week. So it is, there's that recurrent to-do as well. Okay, that's an interesting feature that they have. Synchronize, I'm not sure what that does. Okay, yeah, this is syncing to the server, looks like. Check auth was successful, etc. etc. Do sync. Okay. Yeah, I mean, I'm done from my side. I don't have any, I mean, this purpose of this was to actually try and do an explore unknown repo, and try and discover like the ways in which one can do that. Typically, like if I were to summarize, one is clone all the code locally in a single repo. Right now there's just one repo, so there's not much else to code to clone. Like we can actually look at their other repos. So there are other repos like mobile and front end, and front end shared looks like this will be shared by both mobile and front end, something like that. But yeah, like for now, there's this CLI which also talks to the backend server using the API or backend part. These are all the commands that we can run, and these are all the backend processing, etc. that they have implemented here. So there is no other third-party components. If there were, we would know about them via either application configuration or some other means. That way we know that if there is a database, then there will be some migration related files. If they are not there, then we would need to know what's the state of the database, where are they managing it, etc. Right? So those things come into picture. What the application, like to start with, the before starting with the code, going through application configuration is much more useful, because it really gives you an idea of what all the other component this app talks to, right? And where does it fit in the overall ecosystem or overall components that the overall system may have. So that is super again useful. Okay. Any questions, like is this useful? It is difficult to do this kind of session without a lot of preparation, because I wanted to have a only first look and try to do it myself for the first time. But yeah, if there are no questions, then we can stop the video as well.
Yep, I think we can, yeah.
Cool. All right. Thanks then.
Thanks for the session, Chinmay.